Hello everyone. So let's read over this problem. A sphere is inscribed in a cube, meaning the sphere is tangent to all 6 faces of the cube. A second cube is then inscribed in the sphere, meaning that all 8 of the vertices of this second cube are on the surface of the sphere. Given that the radius of the sphere is 6, find the volume of each cube. So let's look at the first case where a sphere is inscribed in a cube. That's going to look something like this. Now, looking at this, we can see the radius is length with that dashed line. And our sphere is in the cube. And if we rotate it so that we're looking at it head on like this, it gives us kind of a nice picture to work with, where we have basically all the information we need to know to solve the first part of the problem, because from here it should be easy to tell what the side lengths of the cube are. So let's go back and start the problem. So we're going to use this diagram. Again, we know that the radius of the sphere is 6, which means that, well, if we were to just continue, the diameter is 12. So each of these side lengths must be 12. So the volume of the cube, as we can hopefully remember, is just the side length cubed. So that would be 12 to the third power, which means that the volume 12 to the third power is 1,728. I'll call that volume 1 for the first cube. Now we want to examine the case of the second cube, where the cube is inscribed inside of the sphere. Now this one's a little more different to visualize, so it's going to look something like what we have here, where now imagine this sphere is encompassing the entire cube, and like the center could be right here. Well, we know the diameter again is 12. The diameter is this long line from this corner of the cube now to the opposite corner of the cube here. Now, seeing this, it should be noted that like again, our diameter is 12, and the diameter is just the space diagonal of this cube. It's from one corner to the opposite corner. Now, I don't know if we can recall, but there's actually a formula for the space diagonal of a cube. Space diagonal is equal to the side length times the square root of 3. Now, in this case, we know that the space diagonal has a length of 12, since it's the diameter of the sphere. So 12 is equal to the side length times the square root of 3. So let's divide the square root of 3 on both sides. And in order to do this, we would have to do multiplication by the square root of 3 over the square root of 3. So when this simplifies, this cancels out. The side length is equal to 12 times the square root of 3 over 3, which is further reduced. Well, 12 divided by 3 is 4, so it's 4 times the square root of 3 is the length of the side. So from there, to get to the volume of the second cube, well, that would just be, again, the side length to the third power. And so that's 4 to the third power times the square root of 3 to the third power, which, well, 4 to the third is 64. Now 3 times 3, or the square root of 3 times the square root of 3 is 3. So we do 64 times 3 to get 192. But then we have a leftover square root of 3, since it's, again, being raised to the third power. So our final volume is 192 times the square root of 3. And that is it. So the toughest part of this problem is probably just the visualization. Just try to really think about what these three-dimensional objects should be looking like, where things are in relation to each other, and hopefully you set it up right, and from there the math part itself isn't the worst thing in the world.